Section 1611, Lewis acids and bases. So this brings us to the last and probably widest definition of acids and bases. So as Mr. Lewis, Professor Lewis, was looking at simple Bronsted-Lowry reactions that had been known for decades, he realized that in the new definition of Bronsted-Lowry, remember from Arrhenius, was that it wasn't just a generator of protons or generator of hydrogen ions, but it was a proton acceptor. So a proton donor is the acid, a proton acceptor was the base, a Bronsted-Lowry base. A Lewis base is a little bit of a broader definition. He saw that what was happening is that when that hydrogen came into, say, the ammonia, this is an example, it formed a bond. It formed an electron pair. There was no electrons there. The proton has no electrons at all. But after you have a bond, it has now two electrons. That means it accepted an electron pair. So rather than a proton donor and a proton acceptor from a Bronsted-Lowry idea, he said, what if you think about it a little bit differently and say that acid is an electron pair acceptor? Okay, now a lot of people, if they don't study this well, will completely mix it up because an acid usually is a donor of something. It was a producer of hydrogen ions, or it was a proton donor. Well, this is kind of a backwards idea. The hydrogen sitting out there with no electrons, you have to have two electrons to have a bond. So if you're going to have a bond, you need to receive two electrons to make a bond with. So Lewis's idea, and by the way, this is not just called an acid. Normally you call it a Lewis acid. The concept of a Lewis acid is that it's receiving an electron pair. That means that the only thing that's acting as a base has something with an electron pair. Now we already saw that with Bronsted-Lowry. This has an electron pair, so therefore it can receive the proton. Well, Lewis looked at it backwards and said, oh, it's donating an electron pair, so therefore it's a Lewis base. So the idea of base and acid is the same as Bronsted-Lowry, but the concept is slightly tweaked. It's the idea of a donor of an electron pair, okay, that would be a base, or an acceptor of an electron pair, that would be an acid. The benefit of looking at a Lewis acid is that you don't have to have hydrogens. You can have hydrogens. Hydrogens works just fine, but there's other examples that don't have hydrogens that work in an acidic, basic kind of way. So if you're thinking of grabbing an electron pair, okay, so especially if you have something like a sulfur, this sulfur, remember, doesn't have a full octet, or if it does have a full, if it does, it can get more than a full octet. So it has an octet here, but you can, since it has more room, this water could attack it. It's basically attacking it, and if it attacks it, it can grab and form a bond. And that bond then can reconfigure electrons, and you can end up with something like sulfuric acid. That's one mechanism of making sulfuric acid, using this idea of electron pair acceptor and donor. So it's very useful, and it's a kind of a broader, wider definition than the others.